Hello friends, in this video we'll continue our course by creating the certificates and the keys that we will save them later on in the key stores. There are a few points I need to highlight before that. The first thing is that I will not go in details for when I create the certificates. If you want to go in the details and why I'm using this flag or that flag, then you go back to my previous course, the PostgreSQL database and SSL certificates, so you can know exactly how you create the certificates and what are the details about. I'm using here just the basic points to create the certificates and the keys. This is point number one. Point number two, that in this video I'll create the root certificate and the root key. Now the base point of the root certificate, as we have said before in that course, that it is used only the root certificate only used to sign and trust an intermediate certificate, and that intermediate certificate we will use it later to create all the remaining certificates, such as the server certificate, client certificate, trust chain certificate, whichever certificate. The root certificate will not be used after making the intermediate certificate, and especially the root key. The root key, it is very important when you create it that you isolate your environment that you are creating it, such as the laptop or the desktop. Isolate it completely. No Wi-Fi, no LAN card, even the LAN card entrance you plug it. The system you are creating with, you should be encrypted, such as in my case I'm using a Ubuntu server. It is encrypted with the LVM. The place where you are sitting, it should be isolated. So it's totally an important thing that when you create the root certificate, the root key, it should be totally protected, because if the root key have been compromised, any other certificates that have been created from that root will be compromised as well. Okay, now having said that, let me go into the point number 3 in our case, which is this one. Usually the SSL folder and all these things resides in the etc SSL and has 3 files, 3 folders: certs, private, OpenSSL.cnf. Certs for the certificates, private for the keys, and OpenSSL.cnf for the configuration, which, by the way, you need to configure this file prior to creating any certificates or keys, because some of the data in here you will use it when you create the certificate. So first thing first, you must configure this file, then you start creating the certificates. And I have shown you in that course in my PostgreSQL database and SSL certificates how to configure this file. Okay, now having said that, let's start first of all changing the directory. Second, we need to know that we are working now on the system file, on the etc, and on the system file either you use root or sudo user. So make sure that you are using either root or sudo user. So sudo make directory, we will create a directory by the name of intermediate, and then we'll start creating the root key by sudo OpenSSL. We will use genrsa -AES 256 -out private folder, and I will give it a name of root key. You could use whichever name you wish. And strength, encryption strength, I'm using 4096. Now if you're asking me what are all these flags and this, then you go back to my previous course. You will learn in detail what are these things and how do they affect your creation, but here I'm just using them. Okay, now we will put a passphrase. Okay, now we reach to a very important point. You remember in my previous course I said there are 2 types of key store we are using, either PKCS12 or BCFKS, whether it's a Java provider or Bouncy Castle provider. If you are going with the BCFKS12, BCFKS12 key store type doesn't accept that the keys and the certificate have a passphrase, so you should remove them. But in the Bouncy Castle case, if you use the BCFKS type key store, then yes, you can keep the passphrases, it's no problem. Here, I'm using the Java provider, I'm using the PKCS12 key store type, so I need to remove the passphrases from the keys, from the certificates, all of them, before I store them in the key store. And to remove them is easy way. Okay, this is how you remove the passphrase from your key. Enter the passphrase of the key. That's it. Passphrase have been removed. Now we need to change the mode of this key so that only root can access. I'm selecting 600. Okay, now we need to create the certificate from this key. Request -config open ssl.cnf, and we are using the key and then new -x509 extensions v3_ca -out, and I'm saving the certificate in the certs file by the name of root cert. You could give any name you wish, and then I'm giving a period of 10 years for this certificate, 330. Okay, now if you're asking me what are all these flags, again, go back to my previous course and you'll understand what the meaning of each flag and how do they affect creating the certificate. I believe we missed one flag, which is the SHA 256. Okay, now we can start creating the certificate of our organization by give it the country code, state, the company name, the IT division, let's say. The common name. The common name is an important issue because it distinguished your server from other servers by giving the fully qualified domain name or by your name. If you are an organization, if you are a company, then you should have a fully qualified domain name. If you are an individual, then you should have either an email or your name. So in our case here now, we are making the root key, which belongs to one organization. So we should have a fully qualified domain name. And to get the fully qualified domain name, I could show you in here. You could go to sudo nano etc hosts, enter it into the password. Now you see, by default, this line is not. So by default, this is not here. It's just the name of your host, StudyMate Pro, as it's in here. So if you need to get a fully qualified domain name, you need to add your organization website, or in my case, I'm having this. This is my fully qualified domain name, so I'm saving it, and I will use it in here. Then I'm using the email. And that's it. We have now a certificate, a root certificate. Now, if you want to know what are the details of the certificate, you could put this X509. This is the type of the certificate because we have used it in here. As you can see here, we have used it as X509 type of certificate. Now with this line of code, you could open your certificate and check all the details about your certificate. I'm not going through this process again. It's all mentioned in my previous course, the PostgreSQL database and SSL certificate. So, but this code, you can open the certificate, you can check all the details if they are true, what you want or no. Now, this is the root certificate and the root key. The root certificate and the root key with the root certificate will create one time only one or more intermediate certificate, and that's it. Will end any use of the root certificate and the root key. They should be placed in a secure place, in a thumbnail or something, in a totally protected place, and only the intermediate certificate from now on, you will use it to sign and trust other certificates. But the root key, the root certificate will be placed aside. In the next video, we will create the intermediate certificate. Thank you very much.